Okay, Algebra 2, 11.4 is just one short little section right here that's a minor extension of what we've been doing with probability in the last two. So this is called conditional probability, which kind of asks us to look at the probability of an event happening, knowing that something else either has or has not happened ahead of time. So the first thing we're just going to do is introduce a notation that just looks a little bit weird right here. So the P still stands for probability. A and B are still the events, but we've got this vertical bar kind of right here in the middle right here. So we would read this as the probability of B occurring given that event A occurs. So what we're talking about right here is usually something that occurs with multiple events or multiple draws, wanting to know that if one thing happens first, what then is the probability of something else happening after that? So looking at it that way, I just have a couple quick examples for you here, guys. I think you're going to get the hang of this section pretty quick. And I just stole these problems out of the old textbook right here for Algebra 2. So let's take a look at this table that we have over here on the right in green. We're dealing with some job applicants right here, and there's kind of two things that we're looking at right here. First of all, does our applicant have a high school diploma? And the second thing, does that applicant have any experience within their particular job or that field? Now, the one thing you might want to do here, guys, before you get started right here is kind of make an extra little row and column right here on this table that would kind of give you totals. All right, the first thing I'm going to do is add together in this yes column here, the 54 and the 5 means there's a grand total of 59 applicants right here who did have experience. The 27 and the 4 would add up to 31 applicants then who did not have experience. Reading it from left to right now, for the ones that have a high school diploma, we would add the 54 and the 27 together over here on the right, and that is going to be, I believe, an 81, if I'm not mistaken. All right, and the 5 and the 4 right there is going to get us 9 applicants who do not have a high school diploma. And the one thing you'll notice, guys, if you added up the 59 and the 31 right here, you'd get a grand total of 90 applicants. That same thing happens right over here. 90 applicants if we look at it that way as well. So a grand total of 90 people have applied for this job. That's information you have to glean from the table. It wasn't given to you right there. So let's work on answering these 4 questions, guys. But I hope you're going to find this section isn't all that bad. Okay, so number 8, everybody, the probability, there we go, the probability that our applicant right here has a diploma. And this is really the reason why, guys, we added all those things. The line about whether or not they have a high school diploma, that's right here. We'd be looking at the yes column, and that would be the 54 and the 27, which we just added together to get 81 applicants out of a grand total, we said, of 90. So number 8 isn't anything new right here, guys. This is just the same type of probability we've been doing before. 81 of our applicants out of a grand total of 90 have a diploma. And of course, we'd simplify that. We could divide out a 9 and get a 9 out of 10. And I would quit right there and say that's good enough. You, of course, could make that a decimal, 0.9, or you could make that a percentage, 90%. So any one of those 3 forms of the answer would all be fine. But again, I like to make my life easy, not hard, guys. I would have stopped right here at the fraction and been done with it. Okay, how about number 9? What's the probability now that this applicant has a diploma and they have experience? So now we're looking for 2 unique things here. We want somebody who has a high school diploma, so that would be in the yes column right here, or the yes row right here, and also somebody, nope, I read that backwards right there. Has a diploma would be, oh no, that is right, high school diploma. And then also having experience, we want to read out of this column right over here. So that 54 right there, guys, is the number of people we're looking for here in problem number 9. People that have a high school diploma, so a yes here, and also a yes here for them having experience. So this probability in number 9 would be 54 applicants out of a grand total of 90. And again, we would try to simplify that, and I think most of us, I hope, would look at us there and realize we can pull out a 9, and that would get us a 6 over 10. Actually, we could have pulled out an 18. Divide those numbers by 2, and you're going to get a 3 over 5. And if you wanted to be fancy, you could make that a 0.6, or you could make that 60%. All are fine, but again, I think that's the best answer right there. Now, moving on to number 10 and number 11, these problems are new because they contain that goofy little vertical bar right there that we just defined on the previous slide. So we're talking about conditional probability here, and we want to know the probability of B occurring given that event A occurs. You got to be careful about the order here, guys. A is kind of the given right here, which is the second thing that's listed, and B is what we're trying to measure the probability of. So for number 10, we want to know the probability of an applicant here who has a diploma, and we want to know how likely it is that that person already has experience. So the first thing we would want to consider right here is how many how many applicants in total have their diploma. So has a high school diploma, yes, and we said the overall number of applicants with a high school diploma would be 81. That's going to go in my denominator right there. That's the total number of applicants who have a diploma. And now the question becomes, out of those 81 employees with a diploma, how many of them have experience? That would be given to us by this number right here. So 54 out of the 81 applicants who have a high school diploma also have experience right there. So that's what we'd be looking for in this case, guys. Dividing out a 9 here, we'd get, Oh, we can divide out a 27. That actually becomes 2/3. And again, no need to make that a decimal or a percentage. I would just leave it as a fraction there. Okay, so if we're only looking at the applicants then who have diplomas, 2/3 of them also have experience. That's what that one means. And in number 11, let's take a look at this probability. Here, we want to know the probability that the employee has no diploma, the applicant has no diploma given that they have experience. So I would look at the denominator first. The total number of employees that have experience here, we'd be looking over here in the yes column. That would be the 59 employees there who have experience. And out of those 59, how many of them do not have a diploma? No diploma would be right there, which would be 5. So that's a pretty low probability that someone with experience does not have a diploma. And that fraction doesn't simplify at all, so we would leave it as 5/59. All right, so that's that problem right there, guys. Not too terrible of one. So remember with conditional probabilities, you kind of look at this second part right here, and that then becomes your denominator. Okay, that happened in both of those cases with a denominator of 81 for number 10, the total number of applicants who have a diploma, and then the 59 in number 11, the total number of applicants who have experience. And then we're looking just at that first thing right here, experience and then no diploma, and that kind of fills in your numerator. Okay, one more example, guys, bigger numbers right here, but let's take a look at what's going on right here. So we're talking about some type of, let's see here, degree recipients. Oh, so people who are graduating college and receiving a degree, and we've got a couple of different types of degrees. An associate's degree is what you usually receive after maybe 2 years at Kish College or Waubonsie, College of DuPage. Usually it's kind of an intermediate degree saying you're working towards something bigger. And bachelor's is usually what you'd get at the end of a 4-year study, like at NIU or U of I or ISU or something like that. And they've broken it down by gender here in this particular problem. So we're going to go ahead and do what we did a while ago. We're going to add up in our columns right here. So I've just got my handheld calculator right here, and I'm adding up I'm the male column right here. I'm adding up 245 plus 598 to get me 843 total males who received a diploma in this particular year. And now for female, 433 plus 858 gets us a big number here, 1,291. And I'm also going to add going across. The total number of associate's degrees would be 245 plus 433, which is going to be 678 total associate's degrees that were awarded in 2010, and bachelor's degrees, 598, plus that 858 there is going to get us a big number of 1,456. And what I should find real quick, guys, is if I add the 1,476 to the 678, I should get a total now of 2,134. The same thing should happen when I add these two numbers going across. 843 plus 1,291, sure enough, gets us a whopping total of 2,134 total degrees degrees that were awarded here in the year 2010. Okay, so with that in mind, let's take a look at number 12. Here we want to know what's the probability that the recipient of this degree here is male. So I'm looking for the total number of male degree recipients, and that's the number that we found right over here, 843, out of a grand total of how many recipients that we had in total. That's the sum of adding both the male and female recipients out of 2134. And with a big messy fraction like that, guys, I would probably expect that this one isn't going to simplify nicely, so I'm just typing it into my calculator, 843 divided by 2134, and I would write that then as 39.50%. You always want to pay attention to your directions, because they might specifically tell you which format to write your answer in. But as far as I'm concerned, if the directions don't say how to do it, any of the three formats would be fine, guys, either a fraction or a decimal or a percent. Okay, so 39.5% of the total degrees given out here went to males. All right, let's take a look at what's going on in number 13. Now, what's the probability that the degree given is a bachelor's degree? Okay, the total number of bachelor's degrees would come from this row of the table here, which was 1,456, out of a grand total, once again, of 2,134 degrees issued. So I'd go ahead and divide that. 1,456 divided by 2134 gets me 68.23%. All right. So 68% of all the degrees given out were bachelor's. The rest of them would have been associate's degrees. All right, now moving on to number 14 and 15, now is when things start to get interesting right here. And the big key right here is the word given. Now that's kind of taking the place of that bar that we saw right here and right here in problem number 2. So number 14 is asking us, what's the probability that the recipient is female given that the degree is an associate's? So I want to focus on the second part of that first, given that the degree is an associate's degree, and that's going to be my denominator here. And the total number of associate's degrees given out was 678. And we would like to know, out of those 678 associate's degrees, how many of them went to female recipients? And right there, guys, is our numerator. 433 out of 678 associate's degrees were given to female recipients. And I guess I'll be consistent now and go to my calculator once again and type in 433 divided by 678, and I'm going to find now that 63.86% of all associate's degrees went to female recipients. Gotcha. And then number 15 right here. Let's take a look at this probability. We want to know now, what's the probability that the degree is not an associate's, given that the recipient is male? Okay, so again, I'm going to focus on the second part of that. The recipient is male, and that's going to be my denominator. So the total number of male recipients right here was that 843 number down there on the bottom. And what we want to know is that out of those 843 male recipients, how many of them did not get an associate's degree? Well, this is fairly easy because there were only 2 degrees that were given out here, guys, associates and bachelor's. So if we want to know what how many people did not receive an associate's, that just means bachelor's, and that would be 598. This would be harder if there was a third type, like maybe if we were talking about master's degrees here as well. Then we'd have to add up bachelor's plus master's to figure out how many people got something other than an associate's degree. But anyway, this one's about done. We'll take 598 and divide that by 843 and get 70.94%. So to interpret that one right there, out of all the male degrees that were given out, almost 71% of them were not associates, meaning that they were bachelor's degrees. All right, everybody, that's about as much as I have for you right here on 11.4. I think you're probably getting what's going on at this point. So I'm going to tell you guys to wrap this up, to dive into your 11.4 homework. Make sure you're checking your answers, but I think you guys will do okay on that one. And let us know if you have any questions. Good luck, everybody.